The Bayonet AUGV is a highly adaptable platform designed for surf zone exploration. It is made up of 3 individual sections attached by 4 pins and wet-mateable electrical connections. If these pins are removed, the components can be easily taken apart for transportation to and from the worksite. The highly modular construction of the Bayonet AUGV allows it to be quickly assembled onshore, deployed from a vessel, or even assembled underwater by a diver. If you'll notice in the top left quadrant of the screen, you basically have what I refer to as the Google Maps view. So the OpenSea software has the capability of taking TIFF files and actually superimposing them onto the screen. So you have more or less like a background image of where the vehicle is. It gives the end user a little bit more representative physically of where they are. So this is Plymouth Harbor back here. To the left is an old warehouse, and then to the right is more or less open water. There's some jetties and some other marina areas a little bit further to the right. So we're just approaching highish tide. So we've probably got about 3 to 4 meters of water, about 100 meters out. If we look over in the top right quadrant of the screen, that's your forward-looking sonar. So right now the sonar is in air, so you're just seeing what the vehicle would see in the air. Right below that is obviously the video feed. You'll notice in the top left portion of the screen, you'll see DPT parenthesis M, and then below that like a bar chart. That's the depth that the vehicle is at in meters. So we can use that depth as we're recording a mission. The depth is also being recorded across the navigational point. So for every position that the vehicle has touched at a certain frequency, you're also recording how deep it was. What we do for beach profiling is we take a fixed length mast and we use the RTK, X, Y, and Z data. And then because it's a fixed length mast, we know that the bottom is, if it's a 2-meter mast, we know that whatever the RTK-Z measurement is 6 meters below that. So it can give you a very, very precise measurement with the RTK, or the depth sensor is, I think, plus or minus 30 to 50 millimeters. So it actually is a very precise depth sensor on the vehicle. That's a built-in standard function. If you kind of follow that depth screen down on the left-hand side, these are all of your secondary option screens. So the stop button is obviously exactly what it is. It's just a panic button to stop whatever you're doing. It'll stop the vehicle, stop the motors, and just leave it where it is. Right below that, we have a pause button. Moving down, we have checks and then measurement tools. So as you're doing different mission sets, you have different capabilities to measure different features, different distances traveled. Right now, you'll notice that there's a little white dot being placed behind the vehicle as it's going out into the water. So this is what we call the breadcrumb trail. Gives the operator a very good indication of where they have been traveling. And as you move through the water column, you'll see different items. The sonar will pick up different things. And if depending on your visibility of your video, obviously you'll get that video feedback as well. If we go to the bottom center portion of the screen, this is kind of the vehicle diagnostic screen. So in the very center, you have what a typical air pilot would see, your pitch and roll sensors. So the vehicle is set up so that you can actually limit the amount of pitch and roll that the vehicle will see. So in the event that you're going down really steep terrain or need to go up really steep terrain, you can prevent the vehicle from getting into a situation that you otherwise don't want to be in. Just to the left of that, you'll see port SOC and starboard SOC. That is the state of charge of the batteries. It's a visual indication of how much power you have left. As you drain the batteries down and you get further into your mission set, those will start to give you little warning indicators. If it's getting lower, it'll start to go yellow. If it's getting to a point where you need to return to home, it'll go to red. Right below that, we have our Our sensor feedback. So green, sensor is on, sensor is sending data. Grayed out, sensor is turned off. And yellow means that we have a kind of signal, but nothing that the navigation solution is going to use to process.